Coral reefs occupy less than 1% of the ocean floor, but they're actually home to over a quarter of all marine life. The number one threat to coral reefs worldwide is climate change, specifically ocean warming. And I worry that no matter how many interventions that we scientists do, how many reefs that we restore, corals we bring back, if we just keep making the ocean inhospitable to life, I don't think we're going to have corals for our children and our grandchildren to be able to see. My name is Dr. Liv Williamson. I am a program manager at Revive and Restore, and I help bring from idea all the way through operation and into transition genetic rescue projects all over the world for endangered species. Corals I like to think of as part animal, part vegetable, and part mineral all at once. Many people don't realize that they're actually animals with a ring of tentacles and a mouth in the middle. They're part vegetable because within that animal structure, they have lots of tiny symbiotic algae that live in their tissues and photosynthesize. That's what gives them their food. And then they're part mineral because that coral animal actually grabs calcium and carbonate from the seawater and makes a limestone skeleton throughout its lifetime. And that's a huge part of what makes corals really important is that three-dimensional structure that they create, which is really a habitat. Corals are really ecosystem engineers. They built this habitat around which over a quarter of all marine life actually survive. Fish and lobster and conch and all kinds of different animals that survive on these reefs and that we humans also benefit from. And that three-dimensional structure that corals create is also really important as a natural form of sort of a breakwater of breaking waves that helps protect our coastal properties, our beaches, our homes from flooding and erosion. So it's actually a really natural, important form of coastal protection as well. Lots of people go to places in the world with coral reefs, and so they're also really important economic drivers for sort of recreation, for tourism. So overall, coral reefs provide lots and lots of different ecosystem services and billions, if not trillions of dollars to economies worldwide with these services. Sadly, in the last few decades, we've lost over half of the world's coral reefs, and that's due to all kinds of impacts that humans have had all over the world. There's everything from local threats, things like overfishing, which takes the ecosystem out of balance. There's also local stressors like coastal development. But then kind of the big monster of a problem that humans have created, not only that affects coral reefs, but the whole world, is climate change, and specifically ocean warming. And what we're seeing with ocean warming is increasingly severe, increasingly frequent heat waves that are pushing temperatures up kind of beyond that threshold that corals can survive. You may have heard of coral bleaching in the news in the last few years because it's happening very frequently, but basically what that is these high temperatures breaking down the symbiosis between the coral animal and their algae. They lose that algae, and then without that, they starve and die. The good thing is, if a heat wave doesn't last very long, corals can take that algae back up and their color comes back and they can keep surviving and growing. But what we're seeing increasingly with climate change is very intense heat waves that last a very long time. In 2023, the Caribbean, and Florida included where I live, saw an unprecedented marine heat wave that lasted for months. We saw not 1 or 2 degrees Celsius above average temperatures, but 3 degrees Celsius above what the maximum temperature should have been in that area that lingered for months. And this more or less roasted our coral reefs. I unfortunately had the displeasure of diving on these reefs and watching these corals bleach and die before my eyes in a matter of weeks and months. These corals that had been living and growing there for hundreds of years, in many cases, just gone. I was devastated. My colleagues were devastated. We watched these corals die before our eyes. I cried underwater. I mean, it was just horrible. There's a feeling of ecological grief where those of us that work in the field or are even just aware of the nature around us degrading and going away feel a loss that almost feels personal. For actually several decades now, there have been really amazing and robust efforts to try to restore coral reefs through what I would call traditional means. that is protecting various areas of corals so that some of those local threats are taken away. That is also a technique called coral gardening that's become very, very widespread in the last 2 decades, where corals are basically grown. And so that propagation ability, the ability to fragment and grow corals from one individual into many, has been really critical for coral restoration. The problem with some of these kind of traditional restoration approaches is that what you're doing is creating more corals and putting them out onto the reef, but they're not necessarily more resilient or more able to survive the same threats that have caused the need for that restoration in the first place. And so what biotechnology allows us is a new lens to think about ways to actually increase the resilience of the corals that we're using in restoration. Biotechnology is kind of a wide range of things. It's understanding of the building blocks of life, cells and DNA, and how they work and how they might be manipulated, if you will. A next level of biotechnology is biobanking. That can come in the form of cryopreservation or freezing cells and tissues and biomaterials at really, really low temperatures, but keeping them alive. My organization, Revive and Restore, recognized years ago the importance of cryopreservation for corals because we're so rapidly losing their genetic diversity. What biobanking allows us is to freeze that diversity in time. And then finally, sort of towards the top of the ladder, there's also genetic engineering and gene editing. Genetic engineering and gene editing is one of those things that scares a lot of people, right? You hear gene editing and genetic engineering, and maybe you think of GMOs, you think of cases that have gone wrong in the past. But what we're trying to do is leverage those technologies to increase coral resilience. For instance, to look into specific genes that are involved in heat tolerance mechanisms in corals, to rapidly screen hundreds and hundreds of genes within a coral and identify those that are important for increasing heat tolerance. The ability to isolate stem cells from corals just opens up a whole other kind of series of interventions that could potentially be done down the road. And so the ability to do that in a coral would be potentially transformative for increasing their heat tolerance, increasing their disease resistance, even just transferring other metrics of diversity from one coral or one population to another within a coral's lifetime rather than having to breed them. All of these tools already exist. You know, they're not things that are just coming out of science fiction. And so what we're really trying to do is just harness these technologies that already exist and that humans are already using for other purposes and leverage them for wildlife conservation, for endangered species. The future without coral reefs would be a future with a lot of vulnerability for coastal human communities. Many regions of the world would not have about a quarter of the marine species that they depend on. Importantly, the human communities that live along those coasts that rely on seafood for their protein intake wouldn't have that food source anymore and would have to look elsewhere. Without coral reefs, low-lying island nations would be incredibly vulnerable to storm surge and flooding and erosion because they wouldn't have that natural barrier helping to provide that physical protection for them. If I could ask my government and governments around the world one thing to help coral reefs, it actually doesn't have to do with the coral reefs themselves. It would be do everything in your power to address and curb climate change. Despite all of the amazing technological, biotechnological, scientific solutions that conservationists and managers and local people have been able to conceive of and test and put out into practice, I think we're really just buying time if we don't address climate change and try to bring our planet back to something that is habitable and is healthy for all life, not just humans, but all life.